Hello and welcome to this learning video. Here in this learning video, we'll see the application of Laplace transform to solve integral equations. Okay, so you must know what is integral equation. So, an equation in which the unknown function appears under the integral sign is called as an integral equation. As you can see here, what is our unknown? The unknown function is y of x. Okay, which appears under the integral sign. So this is an integral equation. Okay, now there is one another equation which we call is a convolution type of integral equation. So any integral equation of the type like this is called as equation of convolution type. Of course, integral equation of convolution type. Okay, where you will find something like that. Okay, now let us see the problem. So, Laplace transform, application of Laplace transform to integral equations. Okay, so the method of solving and other thing is like very simple. You just have to write down the given equation, take Laplace transform, apply convolution method. So let me give you one method of solving. So step number one, instead of method let me write it as working rule. Okay, so what we have to do in the working rule, write down given equation. Step number one, write down the given equation. After that, take Laplace transform on both sides. Number three, apply convolution theorem. Number four, what we need to do? Number four, take inverse Laplace transform to get the desired solution. Okay, so these are these four simple steps that you have to follow in order to solve the integral equation with the help of Laplace transform. Okay, so I think I should start from here only. Solution, or you just note it down so that I can start solution from here only. So see here now. So what is the first step? The very first step is to write down the given equation. So I can write a given y of t is equal to t plus integration 0 to t y of x into sine t minus x dx. After writing down this equation, take the Laplace transform. Taking Laplace transform on both sides, we get what we get. Laplace transform of y of t is equal to Laplace transform of t plus Laplace transform of integration 0 to t y of x into sine t minus x dx. Okay, apply convolution theorem over here. So it would be Laplace transform of y of t is y of s. So this is y of s is equal to Laplace transform of t 1 by s square, right? Plus, what about Laplace transform of this by convolution theorem? Can you able to write? So pause the video for a few seconds and try to write down the Laplace transform of this using convolution theorem. So I hope you might have written the Laplace transform of this convolution theorem, which is, what is it? Yes, this is by convolution theorem. this is Laplace transform of y of t into Laplace transform of sin t, okay, by convolution theorem. By convolution theorem. Okay, if you want you can write directly also. So this is y of s is equal to 1 by s square. What is Laplace transform of this? So you can write y of s, this is 1 upon s square plus 1. Simple. Now take the term of y of s on one side, so you will be getting 1 minus 1 upon s square plus 1 into y of s is equal to 1 by s square. So when you solve it further, you will be getting s square plus 1 minus 1 upon s square plus 1 into y of s is equal to 1 by s square. This plus 1 minus 1 get cancelled, and when you shift this to here, you will be getting y of s is equal to s square plus 1 upon s power 4. Easy. Okay, so solving this further, you will be getting y of s is equal to s square upon s to the power 4, 1 upon s square plus 1 upon s to the power 4. Taking inverse Laplace transform on both sides, we get y of t is equal to, this is inverse Laplace transform of, if you want I can write one more. Okay, let it be. Inverse Laplace transform of 1 by s square is t. This is inverse Laplace transform of 1 upon s to the power 3 plus 1. So this is t to the power n upon n factorial. So this is t to the power 3 upon factorial 3. This is the required solution for the given integral equation. Okay, now I'm going to take one more problem on this. So let me write that problem here. I hope this problem 1 is clear. Okay, now let me take one more problem, that is example number 2. So example number 2 is find f of t using Laplace transform if f of t is equal to cos t into t minus u cos t, this is cos t minus integration 0 to t minus u cos t minus u into f of u du. Okay, so we are given this equation and we have to get the f of t by solving this equation using Laplace transform. Okay, so let us start with the given thing. So you can start with what we have. Okay, so given f of t is equal to cos t minus integration 0 to t minus u cos t minus u into f of u du. Now take Laplace transform on both sides. So Laplace transform of f of t is equal to, what is Laplace transform of this? Okay, so I need to write one sentence here. Otherwise you may not be able to get what we have done. Not all. Taking Laplace transform on both sides, we get. So what is it? This is Laplace transform of f of t, Laplace transform of cos t, minus Laplace transform of integration 0 to t minus u into cos t minus u into f of u du. Okay, like this. Sorry. Okay, now let us write down the Laplace transform. So what is Laplace transform of this? S upon s square plus 1 minus, now apply the convolution theorem over here. So it would be, what is it? Laplace transform of this. So Laplace transform of this is t into cos t into Laplace transform of f of u is f of s, right? Into Laplace transform of f of u, f of t, whatever you want to write, right? Okay, clear? This is Laplace transform of f of t is f of s, so I will write this entire thing is f of s. Clear? Now here you can give the reason by convolution theorem, okay, that we have already taken. Now f of s is this, so you can write using Laplace transform of t into f of t is equal to minus 1 dds of f of s. Okay, therefore Laplace transform of t into cos t is equal to minus 1 dds of, what is Laplace transform of this f of s? Just a second. Here f of t is equal to cos t, so f of s is Laplace transform of it, so this is s square plus 1, okay, s upon s square plus 1. So therefore Laplace transform of t into cos t is equal to minus 1 dds of s upon s square plus 1, okay, which you can write it as minus of s square plus 1 whole square, okay, and this is first function, start with, okay, s square plus 1 into 1 minus, applying u by v rule here, quotient rule, minus s into 2s. Okay, when you solve this, this is minus 2s square, this is s square minus s square plus 1. So this is 1 minus, and here it is minus sign outside. So this is s square minus 1 upon s square plus 1 whole square. Is it? Yes, we are getting this to be this. Okay, now say this is to be equation, say A. Now I will substitute these value in equation 1. Sorry. Okay, so in equation 1 I will substitute, this is minus s square, this is, yes, this is minus outside, so minus and minus, this would be minus 2s square plus s square minus s square minus 1, yes, so this is s square minus 1. So let me write, this implies f of s is equal to, what is it? Here it is s upon s square plus 1. Equation A imply this plus Laplace transform of this that we have found out, s square minus 1 upon s square plus 1 whole square into f of s. Okay, so this is what we are getting it, minus 1 dds of this. So s square plus 1 minus s square. Okay, fine. So this is what we have. Now just take it to here. So this is f of s common, and we have in bracket 1 minus s square minus 1 upon s square plus 1 whole square is equal to s upon s square plus 1. Simple. Now just try to solve this. So this is now, you can just take the LCM of that. So f of s is equal to, apply here. So it would be s to the power 4 plus 2s square plus 1 minus s square plus 1 upon s square plus 1 whole square. And here it is s upon s square plus 1. Simple. Okay. Now some term will get cancelled. If not, yes, at least one term will get cancelled, s square plus 1. Okay, so just looking at this, s square plus 2s square plus 2 s to the power 4. Okay, so I think okay, it was minus here, sorry, it was minus here, and it should be get plus. Yeah, rest of the thing is fine. So this is plus s square minus 1. Okay, so this minus 1 plus 1 get cancelled. So this is f of s is equal to f of s is equal to, we have already s square plus 1. Okay, so this s square plus 1 is equal to f of s is 1 this get cancelled with this. Okay, and here we have s to the power 4 plus 3s square. Yeah, so here from the numerator we can take okay, just multiply to this. So this is s upon s into s square plus 1 whole divided by, here we have s to the power 4 plus 3s square, right? Now what you can do is you can just solve this like s into s square plus 1 upon, here you can take s square common, so this would be s square plus 3. So 1s get cancelled, so this is s square plus 1 upon s into s square plus 3. Okay, now we have this f of s. Now I want you to solve this by partial fraction method and try to get the value of this. So you can solve this as s square plus 1 upon s into s square plus 3 is equal to a by s plus bs plus c upon s square plus 3. So to get the value of s, you can put 3, 0, s equal to 0 on the right hand side. So you'll be getting a to be 1 by 3. Okay, so this value of a to be 1 by 3. Then to get, then you have to solve. Okay, so how you will gonna solve this? So this is s square plus 1 is equal to 1 by 3 into s square plus 1. Then this is bs square plus cs. Okay, so these are the terms of s. So 1 by 3 plus 1, sorry, 1 by 3 plus b s square, so this is equal to 1, and c there is no term of s, so c is equal to 0. So b is equal to 1 minus 1 by 3. Okay, 1 minus 1 by 3, so this is 2 by 3. Okay, so a is equal to 1 by 3, b is equal to 2 by 3, and c is equal to 0. Okay, I have done it very fast because you all know how to solve these partial fractions. Okay, so I am going to write directly this as, what should I write? A is 1 by 3, so 1 by 3 into 1 by s plus b is 2 by 3 s upon s square plus 3. C is 0, so no need to write. Okay, so you can take this 1 by 3 common, and you can write 1 by s plus s upon 2s upon s square plus 3, right? Okay, now this 3 can be written as root 3 square. Okay, taking inverse Laplace transform on both sides, you will be getting f of t is equal to 1 by 3. 1 by s, Laplace transform of 1 by s is 1. Inverse Laplace transform of this, inverse Laplace transform of 1 by s is 1, and inverse Laplace transform of this is cos 80. Here a is root 3t. Okay, so this is the required solution for the given problem. So I hope this is clear to you. For any doubt, for any queries, you can contact me. So thank you for watching and happy learning. Thank you.